actually. I didn't even have my microphone on, so whatever. Alright. I didn't invest in this video. It's all good. It's all good. Alright, so u plus v. To do u plus v, you just add the x components, so 6 plus 8. And then the y components would be 4 plus 2. So u plus v would have the vector. Yeah. Yeah. 14 over 6. That's how you add vectors. Sweet. Yeah. Yeah. Okay. Subtracting vectors, same thing. Horizontal to horizontal, vertical to vertical. So 6 minus 8, and then 4 minus 2 is negative 2 over 2. Joy. Can I write the or? Let me just write the or. Negative 2, 2. You don't know how IB is going to write this year. You know, I'd be thinking maybe. Oh, yeah, you do. IBers? IBs? IBing. Oh, Lord. Here we go. If you multiply a vector by a number, that number is called a scalar. Yeah, it's a scalar. So basically, if you're taking 3 times u, which is 6, 4, is that 6, 4? Yeah. So multiply those components by 3. So 18 over 12. All right. That's if you're doing like individual components. But now if you're combining vectors, I know. Brian is so excited. Here we go. A, B, C. It's easy as B minus A. All right, here we go. If you want to find vector AB, it's B minus A. It's the second one minus the first one. Yeah. So this is the same thing as 9 minus 5 and 2 plus 3. True? Here we go. What do we got? 4 and 5. Awesome. BC. Yes, love. Did I mess up? Sorry. It's 5 and 4. 2 plus 3. My bad. Horizontal, then vertical. My bad. Yeah. 9 minus 5. So this should be a 5, and this should be a 4. You are right. You are right. My whole world is turned upside down. No? Okay. So BC is what minus what? C minus B. Yeah. So, okay, the horizontal components. Got it. C is 10 minus 2 and minus 9, which is 8 over 14. I didn't flip it this time, did I? Nope. Okay, we're good. Horizontal over vertical. I had it flipped the last time. Sorry. Oh! All right. Let me draw you a picture. Okay? Let me draw you a picture. All right. So, did she draw this one? Oh, yeah, no, this is easy. Okay. All right. This, my dears, right here is called the dot product. Right? And the answer to a dot product will be a scalar. So, if you are taking the dot product of 2 vectors, your answer is not a vector anymore. It's just a number. It's a number. Let me show you how it works. Right. We know that AB is 5, 4. Dot BC is 8 and negative 14. Okay. Here's how the dot product works. It's x times x plus y times y. That's it. It's going to be a plus. Let me show you. So 5 times 8 plus 4 times negative 14. Not 10. Not 10. Which is 40 minus 56. Is it 56? It is. Which is, so this is what I'm trying to tell you. If you're taking the dot product of two vectors, it's a scalar. Yeah? The dot product is also called the scalar product. Okay, let's take this for now and take it in, and then I'll show you more. Yeah? Yeah. What does it mean? I know. What does it mean? It's all good. Yay? All right. There's a transitive property. There is. It's going to be your favorite one. Here's why. If you're adding two vectors together and the middle ones are the same, you can just like that, and then you just got AC. Sweet. Yeah? Here's a picture of it. Yeah. A, B, C, right? So here's vector AB, here's vector BC. That's the same thing as vector AC. Hey! So if they share the same middle, you're good. It's true. Yeah? Okay, we'll just take it like fate. All right, here we go. It's all good. Yeah, we're good. Here we go. So, yes, let's do examples. So, we have C, D, and F. Okay? All right. Since the middles are the same, CD plus DE is going to give you E. Yeah. Right. Okay. Now, this is the same thing as E minus C, right? Sure. Let's go with it. All right. Same thing as before. If you're looking for a vector, it's the second minus the first one. Yeah. Way in the back. I know, it's a lot. Because we're trying to... Why do we subtract? Okay, because back to here, to find a vector, you subtract the second minus the first component. Yeah? Right? Second minus first. Same thing as take it as faith. All right, my followers. Here we go. All right, so subtracting. E is 0, right? So 0 minus negative 5 would be 0 plus 5. And then negative 3 minus 10 gives you, what's that? 5 over negative 13. Yeah. You do? Okay. Okay. Yeah. 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 Thank you. So vectors do have direction. So really quick, I just have to double check something. Okay. Got it. All right. So, yeah. CE is the same thing as EF. Yeah. You're right. You're right. So this would have the same because they're both going the same, like they're both parallel. So this can be written as EF. Why did he want to write it this way? Wait, that's how you change it. Can you even do that? Yeah. Yeah. Do it. But it's the same vector, it's just going in the same different direction. So. Okay, here we go. So, I live on Woodstock Road in Virginia Beach. It takes me like, I don't know, 20 miles to get here. So does my speedometer go back 20 miles to go back to where? To home? Yeah. This is true. So now you have to, if you're switching directions, you do have to switch it. We don't need to do that when it comes to the transitive property though, because it'll take it into account. Later on, when it's not the transit property, we'll think about direction change, but it's the same analogy where this is the same street. Yeah? It's the same road. Yeah? So this is the same thing as CF. Oh, my initials. Sweet. Okay. Yeah. What's up? Why do you flip it? Because you want to cancel the middles. Right? So you want the two middles to be the same. Samia, why can you flip it? Did you miss that hole? Okay. Here we go. So you, like, if this is F and this is E, right? This vector is the same vector as this vector, just going in the opposite direction. True? Yeah. So, I mean, you can flip the vectors. Okay? All right.
Wait, okay, so for this, are we just starting off as scalar quantities?
Yes. Well, there's no scalar for this one, but we're trying to add two vectors together, basically. In order to do that one, I needed the two middles to be equal, so that I could apply the transitive property. Still no? Meh. It's all good. It's all good. Okay. Here we go. So, to solve for CF, it's just F minus C. True? Okay. F is negative 12. And then plus 5. Is that true? And then negative 10 minus 10. So, final answer? Negative 12. Yeah. It's a good time. Okay. All right. I know the little switch threw you for a loop there, but just for our purposes, in order to apply the transit property, you have to have it the same middle, and so you can flip it around for this case. Yeah. All right. Here we go. Ignore him. I'm trying. Here we go. All right. Another key vector word is magnitude. Right. Yeah. Magnitude is the size of your vectors. True. Now, here's the thing. When it comes to vectors, that does not say absolute value. That says magnitude. Okay? So, you're going to have to like put aside your algebra stuff for now, right? And then just think of that is the notation for magnitude for vectors, which is why I keep making you put the little thingy inside, the little vector notation, because otherwise it would just look like the absolute value of V, and that doesn't do, you know, there's only so many symbols, unless you go to China, and obviously there's like a bunch of symbols, right? Yeah, okay. All right. Here we go. Let me take you back to geometry. Here's why magnitude does what it does. Yeah. All right. A is 5. So 1, 2, 3, 4, 5, and then up 2. Down 2. Hang on. Gosh darn it. Here we go. All right. Start here. 1, 2, 3, 4, 5, and then down 2. Oh, that's it. So here's vector A. Yay. Yeah. This is your 5. This is your negative 2. Isn't that a right triangle? So to find the length, right? Isn't that a right triangle? So to find the length of vector A, isn't that just a squared plus b squared equals c squared? Right. Yeah. So it's the square root of a squared plus b squared. Exactly. So yeah, right? If this was ABC, then to find A, that would just be the square root of 5 squared plus negative 2 squared, right? So to find the magnitude of A, it's the square root of 5 squared plus negative 2 squared. So the magnitude of A is equal to square root of 25 plus the 4 is the square root of 29. So that's the length of that vector A. Yeah? Oh, can you do it for a three-dimensional vector? Yes, you can. Yes, you can. Seriously, the cloning. It's the same thing. All right. Oh, wow. Here we go. It's x squared plus y squared. Well, if it's 3, then x squared plus y squared plus g squared. Here we go. 4 squared plus 1 squared plus 5 squared. So to find the magnitude, it's just the square root of the sum of their squares. A. 16 plus 1 plus 25 is 42. Yay, and I'm not going to be mean and make you simplify that because you can't, first of all, but it's fine. It's fine. Yeah. All right. So put a star next to the magnitude. That's a key skill. A key skill. Right? Okay. So now, here we go. No, we're going to do this. We're going to do this. No, this is not part 2. This is not part 2. All right. This is baby stuff. Here we go. Now, if B is the length of a vector, right? There is a vector that is equivalent to B. B is just a scalar of this vector. This vector will have a magnitude of 1. All right? So if it has a magnitude of 1, it's going the same direction, and B is just a scalar. It's the same scalar. We just shrink it down to a magnitude of 1. So a unit vector, hang on. I got you. A unit vector is a vector with magnitude 1. Okay? So the length of the unit vector is 1. Right? This is like how we change everything to the unit circle because we just want the length and the radius to be 1. It could be anything if you want to. The radius could be anything. We'll always go back to that unit circle where the radius is 1. So unit vector, the vector with a magnitude of 1. How do we find it, you ask? Good question. Here we go. For example, right? Let's say that you have vector A is 2, 3. I'm just going to write it in the form that'll irk Miss Panay right now. Yeah. Okay. Here we go. Yeah? All right. So A is 2. So 1, 2, 1, 2, 3 is right here. This is A. Okay. Now, to find that unit vector, there is a vector in each direction, both horizontally and vertically, that is 1 unit long. So the vector from here to here is a unit vector, and the vector from here to 1 point is a unit vector. Okay. And basically, when you add those vectors together and then add it to A, then you could change A to the unit vector. Now, these vectors do have a name. They're called I and J. Yeah, right? Vector I and vector J. Yay? Vector I, sorry? Okay, so no absolute values, no imaginary numbers. Yay, thank you. All right, vector I has the coordinates 1, 0, and vector J has the coordinates 0, 1. Okay? Basically, if you think about it, the x is 1, the y is 0, so this solves for x, and this solves for y. Yay? So you can rewrite A the following way. 2i plus 3j. Yeah. Right? And this is called standard vector form. Yay? Yeah, because if that's I, then there's 2 i's to go that way and 3 j's to go up the other way. Okay? What's up? Yeah. All right. Still working on this unit vector thing. Let's build. Still building. First, we have to know how to write it in standard form, and then we'll continue. Okay. Go away, Bob. All right. Here we go. Did I go too fast? I'm sorry. I go back. There you go. Okay. Writing stuff in vector form, that's the easy part. That's the easy part. You just basically add I and j. I for the x component and j for the y component. It's so easy. Here we go. For example, yeah? What was I doing? Oh, yeah. I just did that, didn't I? Here we go. Yeah. So if CD is 5, 8, then in standard vector form, this would be 8j. I is the x component and j is the y component. Yeah, it's not bad. It's not bad. Sir? Gonna get there. We're gonna get there. So first, this is the standard form for the vector. Then I'm gonna transform it to the unit vector. It's gonna happen. It's gonna happen. So again, all of these little pieces are building up to something. Yeah, hang on. Patience is a virtue is a grace. If you put it all together, you get a happy face. All right. All right. Transform. Negative 2i plus 8j. Speaking of, anybody see that Power Ranger movie? I'm just trying to figure out what that. The trailer came out, right? I'm like, what's really exciting? You saw the Power Ranger movie trailer? But I didn't understand it. I'm like, so there's gonna be more. And dinosaurs. Yeah. What happened? That's your entire childhood? All right. Here we go. So, these two, if you were to take the magnitude of these vectors, the magnitude would not be 1. So, to transform it to the unit vector, to transform so that vector has a magnitude of 1, you take the unit, you take each component of the vector and divide it by the magnitude. I'll show you in a minute, all right? Yeah. So to transform a vector into the unit vector, you take each component, x, y, right, divided by the magnitude. I'll show you why. Okay, here we go. Pretend. What is this, like the relevations? Here we go. Let's say vector A is 3, 4. Yay? Okay. Step 1, find the magnitude of vector A. That's easy. It's the square root of plus. So 9 plus 16 is 25. So it's 5. Yay? Okay. So writing this as the unit vector. Okay, the unit vector of A would then just be, and I'm going to write it all the different ways. Okay? All right, the components are 3, 4. So the unit vector would be 3 over 5, 4 over 5. Oops, go away. Not you. Nope. Okay, let me do it again. Deletes. Yeah. 3 over 5, comma 4 over 5. Or 3 over 5i plus 4 over 5j. Like so. Either one of those would be the unit vector. Why is it the unit vector, Miss Fleck? All right. Let's call this vector vector u now, since it's the unit vector, right? Take the magnitude of u. Yeah? The square root of 3 over 5 squared plus 4 over 5 squared is the square root of 9 plus 16 is 25 over 25, which is just... So the unit vector is a vector with magnitude 1. That's it. Yeah? Eventually. So we learned dot product. There's other things called like the... Yeah. Oh, gosh darn box. Sorry. All right. Okay. Here we go. Take UV. Yeah? If u plus v is equal to w, we're going to go ahead and take the vector form for w. So w, right, is equal to 6 plus 3. True? And 1 plus 2. So that's going to be 9, 3. Yay? Okay. To find the unit vector of it, so the unit vector w, first of all, we need the magnitude. Yeah. Square root of 9 squared plus 3 squared. 81 plus 9. It's easy. 90. Yep. And you could just leave it like that. You can just leave it like that. So the unit vector of this vector will have, the components are 9, 3, right? So it's 9 over root 90, comma 3 over root 90. If it's in that form. Or i's and j's, 9 over root 90i plus 3 over root 90j. Done. That's it in unit vector form. Nope. I'm going to tell you what, making you do all that rationalization thing, that was just for practice. In college, you don't rationalize the denominator. In college, they like to leave it like pretty. It's pretty. No, not true. First of all, you're learning tradition, because there was a time when you could not divide by a rational number because we didn't have calculators. But it's also good practice. No! Craig, you did a good job. All right. Yeah. Yeah. Oh, look, there's more. Okay. All right. Let's do a 3-part vector. All right. If it's 3-part, oh, sorry about that. If it's 3-part, it's not I and J. It's I, J, and K. So I is the X coordinate, K is the Y, J is the Y, K is the X, Y, Z, 3D vectors. Yay! Over your head? It's all good. All right. Wow. Wow. All right. Here we go. I know. What, you guys, I haven't seen you since last Tuesday. We got some catching up to do. Woo! Keep going. Keep going. Here we go. All right, here we go. To find the unit vector of AC, first of all, do we agree that AB plus BC will get you AC? True. Okay, because the B's cancel out, blah, 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 da-da-da, right? All right. Really quick, the components can just be taken off from the equation. So it's literally 3, 5, and negative 4 for this vector. And this vector is negative 1, 4, and negative 1 again. Okay? So when you add it, yes, love. We're almost done, I promise. Come on, you can do it. You can do it. You can do it. Here we go. I know. I'm trying to go fast. Here we go. So when you add it, there's only a couple more. That's it. That's it. Here we go. When you add it together, you just add the components. So 3 plus negative 1, and then 5 plus 4, and no, did I do that right? Yeah. 3 plus, yeah, 5 plus 4, and then negative 4 plus negative 1 would be your AC. True? Right? Which means that AC would be 3 plus negative 1 is 2I plus J. No, adding this plus this. Right? We're adding it together. Add this vector to this vector, so you just add the components together? Yeah? Okay. And then minus 5K? Yeah? All right. Now, this is not the unit vector because the magnitude is not 1. So, in order to find the unit vector, you need the magnitude of AC, which is the square root of 2 squared plus 9 squared plus negative 5 squared, which happens to be the square root of 110. Anyone? Yeah? It's true? Okay. So the unit vector of AC is going to be 2 over root 110 I plus 9 over root 110 J minus 5 over root 110 K. Do you want me to write the other way too, or are we good? We're good? Oh no, you'll do it so much you'll just know. Maybe. I think so. Yeah. They do definitely go over magnitude. Yeah? Okay. Last one? Because I didn't want you to miss this one. Got you. I got you. Yeah. All right. So here's where the direction, here's where the direction of the vector will matter. Okay, Seth? It's going to be all right. I promise. I promise. For which one? Because we didn't have C and A. Right? We didn't have individual pieces. We just had combined vector.
Colors. Can you press the last one?
Good. Okay, sorry. I'm glad you actually read it. Okay. All right. I got you. I got you. All right. Here we go. This one is the tricky one, so I want to walk through this one. Yeah? Well, take a look at it. I have BC and AC. How am I going to get BA? Have to switch, right? So we know that BC plus CA will get us BA. True? Okay. Well, AC, let me bring this down here, right? AC is going to have the components 1, 0, negative 6. True? If you need to go the other way around, you have to switch the signs of your components. The only reason we didn't do it last time is because we were just working with individual components. So for this one, to find CA, it's going to be negative 1, 0, positive 6, right? So switch the signs. Switch the signs. Yay? All right. So BC is 7, negative 2, 1, plus CA is negative 1, 0, 6. Yay? Which is 6, negative 2, 7, which is BA. True? Ooh. Yeah. All right. Yeah. Okay. Next. Magnitude. Ah! Holy Moses. Squared plus negative 2 squared plus 7 squared. Blah. 89. So, the unit vector of BA is all of that over 89. So let me write it without INJs. How's that? So 6 over root 89, comma, negative 2 over root 89, right? Comma, 7 over root 89. Did it ask for INJ form? All right, or minus 2 over root 89 j plus 7 over root 89 k.
So you have to write plus minus.
Yeah. Yeah. Yep. All right. I know that was a lot. I do. And there's going to be a lot of practice, I promise. So that's why it's vital that you start now. I know there's only like maybe 15, 20 minutes left before the bell rings. But take a look. Yeah, at least take a look before you leave at 1 through 28. Oh, yes. Okay. I mean, it's a combination of them. It's like 4 of them where you have to find the magnitude, and like 7 of them where you have to find the unit vector. So like it's just a combination.
Oh no.
Right?